Hi everyone, I'm John Lynn, the founder and chief editor at Healthcare IT Today. We're excited to bring you another in our series of interviews with top leaders in health IT. We're at the HIMSS 2022 conference, and we're here with Bob Rogers. He's AI expert in residence at the Center for Digital Health Innovation at UCSF, and we're with Sri Ambati, CEO and co-founder of H2O.ai. Welcome, guys.
It's great to be here, in person, live.
Yeah, hallelujah, right?
Thank you for having us.
Yeah, so Bob, tell us a little bit. Can you share about the partnership between H2O.ai and UCSF?
Yeah, so we at UCSF receive 1.4 million faxes a year.
Oh, wow.
And they're a huge variety of different types of document. 300,000 of them are referrals. And so right before we started all this work, these faxes were all processed manually by people reading a fax, figuring out what to do with it. Goes into a queue. Someone else reads it, goes into another queue. And so what we wanted to do was automate the technology, build a pipeline that could process these things and allow us to handle each one of them in a much more rapid way, but also reduce the errors associated with the manual processes. Well, we have a team of data scientists and we have many, many faxes, but what we needed was to really pull together the latest technologies, the latest tooling for managing models and AI, and some of the world's greatest experts, and so we turned to H2O to help us with the project.
Interesting, and you guys recently announced Document.ai, which is what they used to solve this problem. Tell us a little bit more about it, Sri.
Document.ai is our foray into making sure the leading source of data today in enterprise is documents and unstructured data over the last 2 years of COVID. And so people are able to take documents, not just specific to one point solution, but solve entity recognition from there, pull out interesting elements from the documents, and start feeding other kind of downstream AI engines so that they can start predicting using documents as a source of data.
Interesting. Yeah, and I think it's interesting. I heard, Bob, that you actually were told that maybe it wasn't possible to do this with structured documents. Talk about that and kind of how it evolved.
We had UCSF brought in a panel of experts to advise us.
Okay.
And after we explained what we were trying to do, they said, well, that can't really be done. It's impossible. And 3 weeks later, our first results came out showing that not only were we able to do it, but we were able to do it with excellent performance. So the whole story there is that the ability to read from a document has to do with putting things in context. So the words have to be in context, but also the shape of the document tells you what the information means. I mean, if you've got a demographics box and a name in it, well, that's a patient name. But if there's just something that says name sitting over here, you've got to figure it out some other way. So the Document.ai technology really allows us to put the language in context and the shape of the document in context using the most recent sort of computer vision and natural language understanding technologies. And sure enough, our intuition was correct. H2O was able to do it, and we got really good performance.
So what have been the outcomes from it? Like, what efficiencies have you gained? What's been the experience for the end users who maybe used to do that job? How are they reacting?
Yeah, well, first of all, they love it. We're heroes in the health system. What we've done is, and this is a huge team of product managers and designers, AI people, software engineers, building a referrals automation pipeline. So the first thing, the document comes in and we figure out what kind of document it is. If it's a referral, it goes into the referrals automation pipeline.
Okay.
The other documents will be going into other pipelines over time.
Okay.
The referrals automation pipeline then extracts a lot more information through the Document.ai process, and then those pieces of information are presented to the care coordinators who can look to see if it's correct, add anything that they need to add, and then it moves on. The impact of all this is we're starting to be able to schedule patients much, much faster. The patients are being sent to the right place. There's no delays because the queues get backed up. The other thing is there's a lot less errors because humans who are doing a really good job of this kind of work are still very variable in how they perform.
Sure.
And so that variability makes it very hard to do downstream processes. And so what we've seen is patients are being scheduled more rapidly. Clinicians are getting more accurate information about the patients that they're seeing, which makes it a better overall experience for everybody. And we're able to now contemplate the next steps in that automation pipeline because the data is now reliably and consistently encoded.
Yeah. So Sri, how good have we gotten at this, right? I mean, this is an interesting example, and the fact that experts told them, no, it can't be done.
I think the key thing is the several major breakthroughs that have happened in the last 18, 24 months in NLP,
Okay.
like the BERT models, pre-built models. And then of course we've had unlocked treasures of wins from the ImageNet over the years, right? So combining them together was one piece of it. But typically customers or partners trying to build software in this, they try to not work very closely together. In our case, we co-created with the help of Bob's team, right, and UCSF, that we were able to kind of learn what they had already done, like for example in labeling. And we found out that annotation, labels, and then training, all of that needs to coexist, as opposed to labeling in some far off place,
Sure.
and then you almost remove the domain expert from the space, right, from the problem solving. And where the AI is wrong, it's interestingly wrong. So you want to go back and re-annotate, relabel, and have the AI learn from those feedback loops. And I think that was the interesting thing about this where we had a tight-knit feedback loop, and over time, that problem generalized from a small set of documents. So the key piece was we did not need to kind of like use a very large corpus. From a small set of documents, we could generalize a solution that would work across referrals of several kinds.
Yeah, you really hit on a really important point, that the very specific question that needs to be answered to make this pipeline work was something that our data scientists and our clinical care coordinators could provide to the H2O team. We could work together to make sure that the exact right questions were being answered, and as you said, the annotation was right, so that really led to a much more complete, applicable set of solutions for the problem.
It's taking pre-built models that are generalized across a wide range of corpus, and then customizing it or transfer learning from that to the local corpus, and making sure we get consistent labeling, and then essentially making sure that we can solve not just one point solution in Document.ai or in that space. Typically you have a lot of brittle point solutions that break when it sees a new kind of document. And I think what we have is a framework that allows customers to not just look at invoices, referrals, right, medical lab tests, and a whole gamut of problems. And that's kind of where our close partnership with customers comes in.
And you're hitting a really important point that's actually a technology discriminating feature for what you did with Document.ai. You're able to tune that model to our data. It's already been trained on a huge amount of other data, but then you're tuning it. That's not always possible with different products. That ended up being really important, and it gave us that extra bit of performance that we needed to be able to go across this very vast array of different types of documents.
And then creates trust for the end user, which I think is key.
Yeah.
So what's next for the use cases? What else are you looking at? Where are you headed with this next?
So, yeah, go ahead.
Let me add to one interesting aspect of it. These are like document processing, OCR, right? They have been around for a while. And what you're seeing is typically leapfrog from the 60, 70% accuracy to mid-90s, 95+% accuracy. Once you go to that level of accuracy and you're applying it for a problem that UCSF and H2O is very passionate about, which is saving lives. A cancer referral is a person on the other side waiting for a match for a clinic, and his tumor is growing rapidly sometimes.
Absolutely.
And so this has meaningful, it's innovation that has meaning and can save lives. And that's where we're super excited about that, about the joint work we're doing, where these documents, once you start reading them with high accuracy, now you can push the pressures downstream and improve the workflows there.
Yeah, no, it's absolutely true. We're on our side. I mean, you've got amazing data scientists on your side, Kaggle grandmasters. I mean, you know, our team is very excited to work with them. We have great data scientists as well because they're really motivated by that mission. It helps both sides really grow. When you asked about where we're going next, there's a whole spectrum of things. I mean, one of them is we're doing a lot more work now since the pandemic in instrumenting virtual care. So finding ways to be connected with patients when they're outside the four walls of the hospital. And that is all work that's AI driven. Clinicians are being driven crazy by the proliferation of text and email messages coming through the EHR. And so we're building technology around routing that information, and just sometimes it's triage, sometimes it's more semantic understanding of what needs to go where, but there's all these different ways to really improve the way we're giving care. And ultimately, I think the biggest impact of this project has been to help people understand what AI actually is. Because we all have an idea of AI. I mean, and we've all seen Terminator. So, you know, there's all these mixed, you know, ideas and emotions. And so when we started, people had this idea that this AI was something that's coming in, sort of trying to displace doctors or, you know, find ways to get rid of clinical care coordinators, all of which wasn't really true. But what this is doing is answering a very specific question. What kind of document is this? What's the name of the patient? What's the referral for? Like very, very specific slices. Now that people have seen it work, they're like,
they want to do more.
Exactly. All of UCSF is sort of buzzing with the excitement of what could happen, and you know, we're getting requests. Oh, could you do this? Could you do that? And in a lot of cases, the answer is yes, with, you know, budget and people.
I think it's pipelining, right? Sort of once you get one solution work, then you can create pipelines that allow for a much larger piece of work to be automated. Or, I mean, it's oftentimes the boring work that comes in the way of how we can reimagine things and patient-centric care. And this boring stuff, which hospitals are ridden with, it kills a lot of the efficiency that would otherwise be focused on making patients more healthier. And I think that's kind of where we are coming in. We're with AI that can remove away the boring stuff. So then the doctors, the nurses, and the entire staff can focus on the important stuff of saving.
Unleashes their creativity.
I will say that the care coordinators who are using referrals automation love it. They're very excited about it. I mean, they're finding their lives are better. It used to be I think a fairly high turnover role, and I think that's changing.
That's awesome.
Over time, I think the number one inertia for AI is trust and safety. So by plugging it into H2O AI Cloud, we're able to continuously validate these models. So we build a model, it's good, but then you need to continuously run benchmark tests so that as data drifts, you rebuild the model so it's up to date. But at the same time, when the model's not right, all models are wrong, some models are useful, can I learn from that where it's wrong so I can improve it again and continue to keep the AI side up to date? And there's an incredible team behind Document.ai, some of them Kaggle grandmasters and some product great folks working with customers closely. But I think that space is still new. And so that co-creation with customers, our vision is to make Bob a world's leading practitioner of AI. Our vision is to make our customers AI first. And to do that, we have to essentially democratize AI, and that means make it faster, cheaper, easier, but also make it part of the day-to-day, so that it doesn't have to stand out.
You know, you make a great point, and you talked about feedback loops. One of the things that we've been really vehement about, and H2O has really helped us with, is making sure that the feedback from when somebody reviews the results from the algorithm, and sometimes they have to correct something, that correction finds its way back into the training data for the next generation of the algorithm. If you don't have that, you don't have machine learning, you just have machine learned.
Yeah, that's really great. Well, thanks so much for sharing this incredible use case, Bob and Sri. This is really interesting and is a great perspective, and it sounds like it's really impactful on your organization, unleashes that creativity. And thanks everyone for watching. If you want to find more great healthcare IT content like this, be sure to check it out at healthcareittoday.com or search for Healthcare IT Today on your favorite podcasting application. Thanks, guys.
Thank you.